Hi, my name is Benito and I am a student at the Hasso-Plattner Institute.
And I'm Max, a PhD student at the Hasso-Plattner Institute.
In this session, we want to present StyleTune, an app for interactively enhancing the result quality of neural style transfer.
But aren't there a lot of apps out there already that do style transfer, for example, Picasso or Prisma?
Yeah, that's correct. However, these apps are mostly one-click solutions where the user has no control over individual aspects of the style transfer itself. We wanted to create an app where users can freely adjust design aspects of the transfer, such as stroke placements and granularity.
So here we can see a few of the results generated by the StyleTune app. Several levels of style granularity are blended together seamlessly to form an image. This can be used to direct the focus on specific elements in the image and have a form of art direction. Furthermore, StyleTune allows us to alter the orientation of strokes in the image.
Current apps for style transfer are quite limited in their output resolutions. To remedy this, in StyleTune we integrated another step to create really high-resolution images. Users can create stylizations with resolutions of more than 20 megapixels. As you can see, we can deeply zoom in and look at all the fine details which have been transferred from the painting, such as paint bristles or canvas structure.
In the opening screen of the app, we can apply different style transfer on a global level onto our content image. Underlying, a convolutional neural network performs the style transfer in a single inference step. In StyleTune, we use feed-forward networks that are trained to reproduce one style per network. However, in contrast to previous style transfer networks on mobile devices, we extend the architecture to enable not only global, but also local adjustments using the same network. We use Apple's CoreML and Metal APIs to accelerate on-device processing.
Our implemented style transfer approach enables global adjustment of stroke scale and rotation. These elements can be freely adjusted in a continuous manner. Adjusting the stroke scale on the global level can be seen as a way to reduce or increase stylistic abstraction of the image. Transferring mostly colors and only subtle structures from the style usually yields a more realistic look. On the other hand, transferring vivid edges and structures conveys a stronger focus on the stylistic abstractions of the image. Similarly, stroke orientation can be adjusted, which is useful as style transfer is very sensitive to the dominant orientation of strokes in the style image. Adjusting the style element orientation thus enables the user to choose the image flow direction, which is an important cue for art direction.
After applying global edits, users can open the local editing interface to fine-tune the results. Local editing allows the adjusting of the same parameters as before, stroke granularity and orientation. Local edits are performed using a brush metaphor that can be applied in real time. Using different stroke granularities yields a visually more pleasing result. Less intrusive lines for the person and the mountain will make them stand out from the background.
To enable an interactive experience, the results for different stroke types are first pre-computed and blended in image space during painting. This result serves as a preview, and on pressing the Compose button, a higher quality result can be rendered. Different stroke edits are then merged in feature space of the adaptive style transfer network to achieve a natural-looking transition between strokes.
Now that we have created our results, we can export and share the image. However, the image resolution is limited to around 1 megapixel, which is quite small compared to typical smartphone camera sensor resolutions. Most apps for style transfer are similarly constrained in the achievable image size, as the key limitation is the GPU memory used by the neural network. To remedy this, the resolution in StyleTune can be greatly enhanced using an additional upsampling step called patch-based style transfer. The method can achieve resolutions of more than 20 megapixels through iterative upscaling while staying in the memory constraints of the device. Creating such high-resolution image takes usually 20 to 30 seconds to compute. When we zoom in, we can see that the results contain fine structures from the image and visually mimics the way a real brush would have created the style elements.
To summarize, we present StyleTune, an app for interactive enhancement of neural style transfer. We implement adaptive network architectures for on-device control over neural style transfer. With the help of our app, users can perform editing of different aspects of the style, such as stroke size and stroke orientation, on both a global and local level. Our user interface allows interactive exploration of these settings and can, in combination with the patch-based upsampling step, deliver very high fidelity images. If you're interested in trying out StyleTune, you can download it at SIGGRAPH with our QR code. Thank you for watching.